side, and they're bringing pieces of rock as big as 23 feet around. And the thing about a mudslide is that mud is a much more efficient medium than water. If you step in water, you just go right through, right? If you step through mud, it kind of holds you up a little bit. If the mud is moving, it can actually wedge these big pieces of boulders on the top of it. And so some of these are 10 feet, some of them are 20 feet. Whenever you see these gravels that are made out of basalt, they'll have this size of material in it, but they'll also have this huge size to it. They won't be very well sorted, but they were probably landslides and glacier moraines that were collapsing up really high, and these gigantic flows that would just come down at a really fast speed, and they would fill the valleys. And if you look at the deposits today, you can see where they've gone through valleys, and you can see where they finally hit the river and kind of spread. And so on the front of Redlands Mesa today, the front of that mesa is right there because it was right about the edge of the valley. So these big flows came down, they hit the river valley, they hit the adobes on the other side, and then they turned and they flowed down the valley this way. And Antelope Hill, if you've ever been down there where the Volcano's Orchard is, that's just a piece of the same thing that's down the valley that shows that all these mud flows just kept on going. They're sitting right on top of river gravels, but they're following the river down. With inverse topography, that's all we see today. We don't, well, except for just a little bit down at the bottom here, we don't really catch the valley sides, but we know a valley had to be there to hold it in, much like the valleys do today. So once you put that together, and then you start doing silly stuff like I do, like adding in what used to be there that isn't there anymore, you start getting a heck of a story with these things. And we can go over Mesa, which is the one right up there, and it's got a little bit of adobes down on the side of it. You see the top of the adobes where they end when you're going up? There, you find about 30 feet of gravel that looks identical to the gravel that we're standing. So we interpret that as the North Fork River gravel, and that's where the North Fork was 2 million years ago. And that was the bottom of the landscape around here. That's where the North Fork River was setting its valley. And we've got 240 feet of debris flow and fan deposits up on the top of it. It's a lot nearer to the glaciers, and the glaciers were just dumping all this water out, and the whole sides of the hills were collapsing and making these big fans up there. So it just filled the valley and just maybe filled it right up to the brim with all these deposits. And that's why the ice ages were so exciting. Right now we're in an interglacial period called the Holocene, and it's kind of a snoozer for geology. We don't have all these big glaciers melting. You know, we don't have these big events going on like we did in the past. That maybe tells us a little bit about climate, that we see all these big events happening in the past, and we really don't see so much of it today. It's just not quite as active a system, which is kind of good for us, really, because it means that we can live on the land and we don't have to watch out for huge mud flows or mammoth stampedes or, you know, all these things that were going on back at that time. But we've still got all this evidence around. Now, I talked about the debris flows coming down and then filling the river valley and